Alright, in this tutorial video I want to talk about covalent bonding. I have two videos on ionic bonding already on YouTube. So if you have any confusion about ionic bonding, just look those up. So covalent bonding, the definition, remember, is that we have nonmetals, two nonmetals attracted to each other. And so they form a bond. Some examples would be carbon monoxide, and we looked at how to name those today. We have to use prefixes with these because we can form several different compounds with the same elements, and we need some way to distinguish what their formula is, because that lets us know which compound we have. So this would be carbon monoxide, because I have only one oxygen and one carbon. This would be carbon dioxide. The di lets me know that there are two oxygens in that compound. It's based on the octet rule, just like ionic bonding. Everything wants to get 8 electrons, and so we have to look at the Lewis dot diagrams again for each element. So for carbon dioxide, carbon has 4 valence electrons because it is in the 4th column of the periodic table. Oxygen has 6 valence electrons because it's in the 6th column of the periodic table. And I have 2 of them. That's what that subscript 2 lets me know. So the oxygen wants to borrow 2 of carbon's electrons, and carbon would like to borrow 2 of oxygen's electrons. So what happens is you have a sharing of 4 electrons, 2 from carbon, 2 from oxygen. And on the other side, same thing, a sharing of 4 electrons. If we share 4 electrons, or 2 pairs, that gives us a double bond. We draw 2 lines to show that it's a double bond. So that is carbon dioxide. Okay. Let's look at H2O, water. So again, we start by looking at the Lewis structure. The other thing that we need to keep in mind is the center atom. The central atom is the least electronegative. Remember, that means it wants electrons the least. And we also need to remember that hydrogen is never a central atom. It's always going to be on the outside. So for this example, we'll have oxygen in the middle with its 6 electrons. Here. And then we're going to have hydrogen with its 1 electron, because that's the number of valence electrons that hydrogen has. So we have these electrons sharing between the 2 atoms. So hydrogen, oxygen, hydrogen. I draw it a little bent like that because of these lone pairs of electrons, is what we call these, because they don't bond with anything, they're just stuck there by themselves, which means that they take up all this extra space and actually bend the hydrogens down a little bit. But that's a water molecule. Okay, let's look at another example. Let's look at let's look at a molecule of carbon tetrachloride, CCl4. This is carbon, and if we think about naming the compound, we name the first element first, and then we tell, since it's a covalent compound, we tell how many of the second element we have using the prefix. Tetra means 4, so tetrachloride. Carbon tetrachloride. Carbon is going to go in the middle. It has 4 valence electrons, again, because it is in the 4th column of the periodic table. Chlorine is in the 7th column. It has 7 valence electrons. 3, 4, 5, 6, 7. 1, 2, 3, 4, 6, 7. 1, 2, 3, 4, 5, 6, 7. So these two share, these two share, these two share, these two share. When I do that, I wind up having 8 electrons. There's 2, 4, 6, 8. Remember, the octet rule says every atom wants to have 8 electrons. I could look around each chlorine and say I have 2, 4, 6, 8. Every atom has 8 electrons, and so we've satisfied the octet rule. So this would be carbon, Cl, Cl. This is actually a 3-dimensional shape, so in order to draw it 3-dimensionally, I got to put one chlorine going back into my iPad and one chlorine coming out of my iPad. But that's not the most important thing I want you to get out of that. I want you to understand that every atom around here has 8 electrons. That's the goal. To get that, they had to share. Carbon had to share 4 of its electrons with chlorines, and the chlorine had to share its electrons with the carbon. Okay, let's look at one more. Okay, CH3I. Now, again, the least electronegative element is the one that goes in the center, and hydrogens never go in the center. So carbon is less electronegative than iodine because carbon is in the 4th column, iodine's in the 7th, means it really wants that last electron, so carbon's going to be in the center. Carbon's almost always in the center. So it has its 4 valence electrons, and then I have one iodine, which has its 7 valence electrons. Then I have 3 hydrogens, which have 1 electron apiece. So what's going to happen? These will share 2, 4, 6, 8. That gives 8 electrons around the carbon. I have 8 electrons around the iodine. Each hydrogen has 2. Hydrogens are exception to the octet rule. It only wants 2. So my compound would be carbon in the middle, single bond to the hydrogen, single bond to the iodide, single bond to the other 2 hydrogens. Okay. All right, if you have any questions on covalent bonding, make sure that you let me know in class. Remember, covalent bonding is between non-metals only, and we are sharing electrons. Okay, have a great night. I forgot to give you a tutorial assignment for this one. So on the next slide, I'm going to put your assignment question up here. So your assignment question is going to be to draw the Lewis dot for CH4, and then I want you to name this compound. H2S. So give me the name for that carbon and draw the Lewis dot structure for CH4. Okay, now have a great night.